Hey everyone! Welcome back to the channel. If you're into coding, problem solving, and smart programming tricks, you're in the right place. Subscribe and level up with CodeWithRam.
Today we're solving one of the most famous coding interview questions, Roman to integer. Let's first understand the problem clearly. You are given a string that represents a Roman numeral, and your task is to convert it into an integer. Roman numerals use specific symbols to represent values. For example, I represents 1, V represents 5, X represents 10, L represents 50, C represents 100, D represents 500, M represents 1000. Now, at first glance, it seems simple. Just add all the values together. For example, 6 equals 5 plus 1, which is 6. But here's where things get interesting. In some cases, a smaller number appears before a larger number. When that happens, instead of adding, we subtract. For example, 4 is 4, not 6. 9 is 9. XL is 40. So your task is to correctly interpret these rules and convert the given Roman numeral into its integer value. And the challenge here is to handle both cases, addition and subtraction, efficiently in your code. 4 is 4. 9 is 9. But why? Today, we tackle LeetCode 13, Roman to integer. Roman numerals use 7 core symbols, I, V, X, L, C, D, and M. Usually, we just add them up from left to right. For example, 12 breaks down into 10, plus 1, which equals 12. But here's the key rule. If a smaller value appears before a larger one, you subtract it. Otherwise, you add it. That's it. One simple pattern replaces all the memorization. Let's trace a real example. MCMXCIV. Starting from the left, M is 1,000, and since it's bigger than the next character, we add it. Total, 1,000. Next is C, which is 100. But the next character is M, 1,000. Since 100 is smaller, we subtract it. Total, 900. M again, add 1,000. Total, 1,900. X is 10. Next is C, so subtract 10. Total, 1,890. C is 100. Next is I, so add it. Total, 1,990. I is 1. Next is V, so subtract 1. Finally, V is last, so add 5. Final total, 1,994. Now, let's translate this to Python. First, we create a dictionary mapping each symbol to its value. We initialize a total at 0. Then, we loop through the string. Inside the loop, we check 2 things. Are we not at the last character, and is the current value less than the next value? If yes, we subtract the current value from the total. Otherwise, we add it. After the loop finishes, we return the total. This approach runs in O of n time complexity because we only scan the string once. Space complexity is O of 1, since our symbol map never grows beyond 7 entries. Master this pattern, and you're ready for the next challenge. The time complexity of the solution is O of n. Why? Because we iterate through the string exactly once. Hey, n represents the length of the input string, so this is a linear scan, which is optimal for sequential access. The space complexity is O of 1, which means constant space. This is because the map we use contains a fixed number of entries, only 7 symbols. So the memory usage does not grow with the input size. So overall, we have an efficient solution with O of n time complexity and O of 1 space complexity, making it both fast and memory efficient. Let's quickly summarize what we've learned and take it one step further. Here's the key takeaway. Identify the pattern. If a smaller value comes before a larger value, we subtract. Otherwise, we simply add. Now for a quick challenge. Try solving LeetCode problem 12, integer to Roman. It uses a similar greedy approach, but in reverse. Can you solve it using the same mapping logic?